Hello everyone. Today we're going to be doing the P5 end of year mock exam paper. Just a brief introduction about myself. I am teacher Ling and I teach primarily math and science. And I have been teaching for the past 15 years and trained many teachers and coached many students to achieve their learning goals. I have a keen interest in education technology, so you may see that popping out right now. An interesting fact about me is that I play the drums. Without further ado, let's move on to the paper. Now, if you haven't had a chance to attempt the paper, please go and download and try it out first. Give yourself 1 hour for paper 1 without a calculator, and then take a short break, and then you can do paper 2, 1.5 hours with an approved calculator. So let's move on to take a look at paper. So booklet A is MCQ 15 questions. So let's get into it. At any point in time, please pause the video if you think that you have already gotten a hint, and then try it out yourself to see whether you can get the final answer. Okay, first question, 1 mark. 20 tens, 2 tenths with a THS, and 100, 2 hundredths. What does it equal to? So 20 tenths is 20 multiplied by 10, which means that this is 200. 2 tenths is 2 multiplied by 0.1. So this gives me 0.2. 2 hundredths is actually 2 times of 0.02, 0.01. Excuse me. So this will be 0.02. When you add these together, this is on decimals and place value. You can add extra zeros to help you to see how we can add. So your final answer will be 200.22. Okay. Option number 3. Next question is on rounding with decimals. Round off 74.56 to the nearest 10. So let's take a look at where the 10th place is, which is this number. So always look at the place value and the one after it. So the one after it is the 100th place. So this is the number 6, which is more than 4. So 5 and above, you have to round. Okay, so we'll round it up. So your 5 needs to become 6. So the answer will be 74.6. This is a conversion of fractions to decimals. So we have 3 and 7 over 20. Now, 3 stays as 3 wholes. For 7 over 20, when you want to convert to decimals, you make the denominator a power of 10. What do I mean by that? So either make it 10 or 100 or 1,000. So in this case, we will turn it into 100. How does it turn to 100? Multiply by 5, the numerator and the denominator, and you get 3 and 35 over 100. So the answer is 3 points. So 35 over 100 means 35 hundredths. Let me just write it so that if you see this in English somewhere else, this is what you can do. 35 hundredths just means that number over 100. So this is 3.35. Question number 4. This is an order of operations question. Find the value of 120. See the sign over here, it's a subtract. And then we have divide, multiply, and then plus. So for order of operations, division and multiplication take priority over subtraction and addition. That means these 3 need to be worked out together from left to right. All right? So there's no need to put a bracket because they are already prioritized, but I shall put a bracket. It doesn't make a difference, but we should be looking at this first. So 90 divided by 10 is 9. Then when you multiply 9 by 3, you're going to get 27. So do it from left to right. Okay, because it doesn't mean that multiplication is more important than division. They have an equal weighting. So we'll take 120, then we subtract 27 and add 40. All right, so when you subtract 27, so no calculators allowed. So this will give you 93. And then you add 40 to that, you get 132. The answer is option number 2. Moving on, now we have a trapezium. So this is a 4-sided polygon, a trapezium. So what are the properties of a trapezium? A trapezium has one pair of parallel lines. So if you look at this, even though the diagram is not drawn to scale, we'll be able to observe that these two lines are parallel. So I'm going to put my arrowheads there. So if you observe parallel lines, you should be able to observe some properties about angles. So I'm going to use highlighter for us to see that these are the parallel lines, right? And what joins the parallel lines is another line. So you can spot this and call it the C. So when you spot this, you know that the interior angles add up to 180 degrees. All right. So it's very important to highlight the parallel lines, then figure out which line joins them in order to spot your interior angles. Okay. So this is untrue because it's not that they are equal, it's that they add up to 180. Okay. The opposite angles are also not equal because this is not a parallelogram. So only in a parallelogram is when your opposite angles are equal. So the answer is option number 3. Question number 6. Let's read the question. At a school carnival, there were 120 students. So it's important to spot the clues. 45 of the students were girls. So what does this mean? The hidden number will then be the number of boys. So to find the number of boys, we can take 120, subtract 45, and we will get 75. This is the number of boys, the number. Reading the question again, what is the ratio? They want boys to girls. So I will write my header for the ratio over here. The boys is 75, while the girls is 45. So take note of what the question wants. Boys to girls. Now, boys to total, not girls to total, but boys to girls. So we can reduce this. Now, if you cannot divide by 15 directly, we can divide it by 3 first. To get 25 is to 15. Then we divide by 5 to get 5 is to 3. So for paper 1, without a calculator, you can divide by single-digit numbers rather than dividing by a double-digit number. So the answer is option number 3. Moving on to question number 7. 40% off. The word off is very important. When we see this, we are like translating English to math. So of a number is 600. So is 600, the 600 refers to the 40%. Okay, so what is the number? This tells me that 40% is 600, or you can think of it as 40 units is 600. The number is 100 units. So when 40 units is 600, now, because this is paper 1, if you try to find 1 unit, you could do that, but it's going to take a lot more time. So remember, begin with the end in mind. We're trying to get to 100 units. So from 40 units to 100 units, the middle step, we can find 20 units. So we can divide it by 2 first to get 300. So this is easier to work with without a calculator. And then we multiply by 5 in order to get 1,500. And this is the number. All right, so the answer is option number 1. Next, express 1/5% as a decimal. So this is percentage conversion. So quick recap. When we want to convert percentage to a decimal or a fraction, we need to divide by 100%. What does this mean? For example, 50%. To convert to a fraction, we divide it by 100%. So the symbols are gone now. So 50 over 100 is 1/2. That's how we get 50% conversion to half in the fraction. All right, so, oops. Let's erase this. Okay, So from fraction back to percentage is the opposite. You multiply by 100%. So now here we have a percentage that needs to be expressed as a decimal. So we will be dividing this by 100. The options are given in decimal. So we can convert 1 over 5%. It's the same as 2 over 10%. So this can be your thinking. You don't need to write all these down. That means this is 0.2%. So how do I convert 0.2 into a decimal? Remember, divide it by 100%. So I'm going to move how do we divide a decimal by 100? I will move the decimal point to the left twice. So I'll move it once, and then I'll move it another time. Okay, so this means that my decimal point is here, and I have a 0 over here. So it's actually 0.002%. And this is the answer, option 1. Moving on. What is the missing number in this blank? Is to 24, which is the same as equivalent ratio is 25:40. So when we have such questions, do not attempt to convert directly. Instead, you should take the ratio and simplify it. So 25:40 can be simplified further by dividing by 5, and I will get 5:8. So when you divide it, you get 5:8. Now, you're trying to get the answer in the blank. But you know that this number must be 24. So equivalent ratio will multiply by 3. So when this becomes 24, the number 5 multiplied by 3 will give me 15. And that's the answer. Option number 3. Question number 10. Jacob had 12 kg of flour. He had 20% more flour than John. So this is very important, this wording here, 20% more than. If I were to express this in ratio, it means that the word after the word then is the 100%, the base. Okay, so I'm just going to write this down. So more than John. So let me ask you, does it mean that Jacob to John is 100:80? This is a very common mistake. This is incorrect. Okay, so 20% more flour than John means that. We look at the word then. We'll just fix John as the 100%. Here, 20% more flour means that Jacob is 120. So when we write in terms of ratio, this is what we get. So all this means is that Jacob had 12 kg of flour. So you can either reduce this to its simplest form or immediately convert Jacob to 12. That means you're dividing by 10. So John will be 10. So 12:10. John will be 10 kg. Now, another way of thinking about this, I'll do it in a different color, is we reduce it further and we'll get 6:5. So this means that 6 units, Jacob, is 12 kg. We can solve for 1 unit and we can find John. Oops, they're both J's. So John will be 5 units, which is 10. Okay, so 2 methods in order to get your answer of 10 kg. Option number 2 is the answer. Okay, first 10 questions are worth 1 mark each. Try to spend 1 minute per mark. So we go on to question 11 to 15. These are worth 2 marks each. So let's read carefully. The diagram shows 10 squares and hearts. How many more keyword unshaded hearts must be added such that 4/5 of the hearts are unshaded? So what kind of question is this? We said 4/5 of the hearts are unshaded, but we are adding unshaded hearts. So we need to think about what does not change in this question. So if we are adding unshaded heart, it means that the number of shaded hearts doesn't change. So we are not adding shaded hearts. Okay, and if we read carefully, they say of the hearts. So we can ignore the squares now. We are only focusing on the hearts. So if you look at this, these 2 hearts, this represents 1/5. Okay, so 1/5 of the hearts are going to be shaded. So 1/5 of the hearts will be 2 hearts. So if we are trying to find 4/5 of the heart, from 1/5 to 4/5, we multiply by 4. That means we need to have a target of 8 hearts. But right now, there are 4 hearts. To make them 8, we need to draw another 4 more unshaded hearts. So let's count. So if I were to draw 4 more unshaded hearts, I will end up with 10 hearts total, with 2 that are shaded and 8 unshaded. Isn't that the same as 8 unshaded? 8 into 10. So the answer is 8 subtract 4 to get 4 unshaded hearts that must be added. All right. Now, if for fractions we're not very sure, we can always draw a model. Okay, so I'm spending a little bit more time here to analyze the wording. So if I have 4/5 that are unshaded, it means that my entire okay, so the shaded part will be here, and there are 2 hearts that are shaded. So doesn't that mean that there will be 8 hearts that will be unshaded? Because each of this is going to 2, 2, and the current count of hearts is 4 hearts. So we take 8 minus the current count, we will also get 4 hearts must be added, 4 unshaded hearts. All right, so we need to look at what comes off to understand why we zoom into the hearts and we can ignore the squares already. Okay, question number 12. Which of the following fractions is closest to half? All right, so let's think about fractions in general. When you have the same numerator, so let me just write down some fractions. Okay, the one with the smallest denominator will actually be the smallest fraction. Okay, that makes sense, right? If I have 1 pizza and I split it among 6, versus if I have the same pizza splitting it among 9, this is going to be a smaller number. All right, so that's one thing we need to understand. So closest to half. So we can actually find the difference between this fraction and half. But how do I take 2/3 subtract half? So 2/3 is the same as 4/6. And half is the same as 3/6. So when I take 4/6 minus 3/6, I'm going to get 1/6. So this is the difference between half and 2/3. Okay, so 3/4. 3/4, how do we subtract half? So half can be converted to 2/4, same denominator. So we are essentially converting letting the denominators be the same when we're trying to subtract. So this will give me 1/4. Immediately, I can rule out option number 2 because I know that 1/6 is smaller than 1. That means 1/6 is closer to half than 1. And let's try with 5/6 subtract 3/6. So this is very clearly larger than option 1 because this is 1. So this is also out. All right, then for 7/9, how am I going to take 7/9 and subtract half? So 7/9 subtract half is the same as changing the denominator to 18. So 14 subtract 9 gives me 5/18. If I compare this with 1/6, which is the smaller fraction? So 1/6 can be converted to 3/18. So this 3/18 is smaller than 5/18. Therefore, option number 1, that fraction 2/3 is closest to 1/2. Question number 13. Looks like a very long, complicated question, but let's read it slowly and carefully. So Jillian had a mixed 10 cent and 20 cents coins. And Kaylee only had 20 cent coins. Jillian then used all her 20 cent coins to buy stationery and had 14 10 cent coins. Now, if you see 14 10 cent coins, you can actually find out that this is 140 cents, which is the same as $1.40. So you can either immediately work with decimals in money, or you can work with whole numbers in cents. All right, so I'm going to work with whole numbers. So $4.80 is the same as 480 cents. So if this is what Jillian had left, it means that we need to add the 480 in order to find out how much Kaylee had. So this is easier to add, 620. So how many 20 cent coins did Kaylee have? So if this is the value of Kaylee's coins, and they are asking for the number of coins, we need to take 620, divide by 20 to get our answer. So how do we do this without a calculator? 620 divided by 20. I like to put it in a fraction. This is a trick we can do, okay? Because the division is the same as putting in a fraction. So 600 divided by 20, you can divide by 10 in the numerator and denominator to get 62 over 2. So 62 divided by 2 is a lot easier to work with. So you will get 31 over 1. You get 62 divided by 2. So the answer will be 31, and that gives me option number 2. Question number 14. In the figure, WXZ is an isosceles triangle. So what's an isosceles triangle? It has two sides that are the same as indicated over here. Now, in an isosceles triangle, the property about it is that the base angles are the same. All right? And you need to identify what is the base angle. So let me leave the property over here. When I have an isosceles triangle, base angles are equal. It doesn't look very much like one. Here we go. Okay? So base angles of an isosceles triangle are equal. Now, we are told to find angle XWY, and it has already been pointed out to us. So it will help us to find out what is this angle here. So if we can find this angle over here, and then find this angle here. All right, so we need to find angle WZY. How do we find it? We can first find this angle here. So 180 subtract 84 will give me 96 degrees. And 96 is not the answer. I'll take 180 because of angles in the triangle added up to 180. So the three angles here add up to 180, right? So I'll take 180 and I'll subtract 96 and I'll subtract 20 degrees to get me. So you will notice that 186 minus 96 is just 8. Okay, this is a property we don't really use, but it helps. That is, the outside angle is equal to the two inside angles, two opposite interior angles. But it's okay, we can find the 96 first, we subtract, and we find that we get 64 degrees. So I'm going to just quickly label this here as 64 degrees. Where else do we find 64 degrees? The other base angle is 64 degrees. So in order to find XWY, you see that we can spot another triangle. XWY. So what is this angle over here? It will be 180, subtract 64, subtract 84, because angles in a triangle add up to 180 degrees. So again, you will get 96 minus 64, 32 degrees is the answer. So the answer is option number 1. All right. Moving on to question 15, the last question of section A MCQ. Rates question. So printer A can print 60 sheets of paper in 45 seconds. Printer B can print 20 sheets in 20 seconds, and they both started at the same time. How many sheets can both printers print all together in 6 minutes? So we have minutes here and we have seconds over there. It will help us to find out how many sheets of paper printer A can print in 1 minute. Okay, so let me just write this down. So for printer A, we know that 45 seconds, I can print 60 sheets. So instead of finding 1 second, we can get, remember what we're trying to get to? We're trying to get to 1 minute, which is actually 60 seconds. So a good middle ground would be 15 seconds, right? So that we can divide by 3. So 20 sheets can be printed in 15 seconds. That means in 60 seconds, multiply by 4, you will get 80 sheets. So that's in 1 minute. Why does that help me out? Because with 1 minute, I can get to 6 minutes easily later. So then let's focus on printer B now. For printer B, 20 seconds of printer B can print 20 sheets. So we're trying to get to 60 seconds. So don't try to find, you could try to find 1 second, but that will not be as useful as just immediately going to 1 minute, which is 60 seconds. So I'll multiply by 3, and I'll get 60 sheets. So we take a look at these numbers. So 80 sheets in 1 minute for printer A and 60 sheets in 1 minute for printer B. So both working together, they can print 140 sheets, 60 plus 80, and in 6 minutes, this is what we can get. So 140 sheets per minute multiplied by 6. This should give you 840. And the answer is option number 4. Okay, so we're done with booklet A, 15 questions of MCQ. Let's move on to booklet B, which are short answer questions. Now, booklet B is also 15 questions. In the 15 questions, there are 5 1-mark questions and 10 questions that have 2 marks. So 16 to 10 is 1 mark. So let's start. Question number 16. Find the value of 5, subtract 1 over 9, subtract 2 over 3. So we are subtracting 5 minus 1 over 9. Let me rewrite the question. Fractions that have different denominators. So let's just make the fraction, the denominator, the same. However, if you look, I have 5 wholes. How do I take away 1 over 9 and 6 over 9 from 5 wholes? So one way is to split the 5 wholes into 4 wholes and 9 over 9. Isn't that the same as 5? So I can write it this way. And when I do my subtraction, I will get 9 minus 1 minus 6. So 9 subtract 1 subtract 6 will give me 2 over 9. And that's the final answer to this question without a calculator. Moving on, find the value of 0.62 multiplied by 30. So when I do this, there are multiple ways to solve such a question. You can either do 62 multiplied by 3. To do that, okay, you can think of, or you can go directly to do the decimal, but you can think of it as 0.62 multiplied by 10. Then you multiply it by 3. So 0.62 multiplied by 10 is 6.2. And when you multiply it by 3, you get 18.6. There is no one way to get to the answer. There are many ways to get to the answer. Okay? Moving on. A cup can hold 700 milliliters of water. How many such cups are needed to fill a container of 4.2 liters to brim? So 4.2 liters would be referring to the capacity of the container, and we can convert this to milliliters. So we multiply by 1,000 in order to get 4,200 milliliters. And when we divide this by 700, we'll get our answer. Okay, so how do we divide? So even though there are two zeros, we can simplify. It's actually 42 over 7, or 42 divided by 7, which will give me 6. And that's the 6 parts I needed. Question number 19. The table below shows the postage charges by a post office. So we see this term here, mass step, this phrase here, knocked over. And then we are given every additional 50 grams. Now, this is only a one-mark question. Okay, so if we look here, Jacob wants to send a parcel that weighs 420 grams. So 420 grams actually is between 300 and 500 grams. So mass step not over means that any parcel 300 grams and below, not over 300 grams, will be 380. Any parcel 500 grams and below, not over 500 grams, will be 530. Okay, so what this means is that as long as you exceed 100 grams, you're going to have to pay this amount. If you exceed 300 grams, you're going to have to pay this amount. Every additional 50 grams only refers after 500 grams. All right, so you actually do not need this number. The answer is $5.30. You just need to state. Next question, number 20. A whole number, when rounded off to the nearest 10,000, is 600,000. What is the greatest possible value of this number? So for such question, I like to draw a number line. And we know that the number rounded off gives me 600,000. So we are actually either rounding down or we are rounding up. This word 10,000, I will write 6. I will put plus 10,000 this way, and I'll subtract 10,000 this way. Okay? So we need to figure out what is the largest possible number. I like to tell my students that 4 and 9 and 5, these are magic numbers. Just leave them inside. Okay? So right in the middle over here will be 605,000. Right in the middle over here will be 595. So the question wants the greatest possible. Now, we know the smallest possible number will be this, where we can round up to 600,000. Any number smaller than 595,000 is going to round down. All right? And then we have this number, which will round up to the nearest 10,000. Okay, nearest 10,000. I hope I said the correct thing just now. So 605,000 will be rounding up to 610,000. So what will round down? What's the largest possible number that will round down to 600,000? So you're actually going to take 605,000. You subtract 1 and you get 604,990. Get 604,990. Okay. So usually a quick formula would be that the smallest number, we'll take 10,000 and we divide it by 2. So the smallest possible number that rounds off to 600,000 will be 600,000. Subtract 10,000 divided by 2. Okay, as shown in the number 9. The largest possible number is a little bit different. We take the number we want it rounded off to, add 10,000 divided by 2, but we still minus 1. Must remember to subtract. Okay, But I always think that the number line helps us to see why we can do it this way. All right, so we're done with the 1 mark questions. Let's move on to the questions that were 2 marks each. So question number 21, question number 30 carry 2 marks each. So let's look at this. Okay, in the figure, WXYZ is square. So with this square, and we are given straight lines, it splits up the square into 4 equal parts. Okay, so these 2 lines will split up the square into 4 equal parts. Right? But at the same time, each triangle over here can be split even further. All right? So we're asked what fraction of the square is shaded. We can actually split it up into smaller pieces, and we either can do a cut and paste and move this over here to uncover immediately that 1/4 of the square is shaded. Or we can think in terms of units. So each of these small triangles, if they were to be 1 unit, it means that each of the larger triangles here is 1, 2, 3, 4 units. So I'll write 4 units over here and here. So in total, we have 16 units. The square is 16 units. And the shaded part is 4 units. So the answer will be 1. So either by observation, we get the answer by doing a bit of cut and paste, or by labeling each of the smallest parts as 1 unit. All right, moving on. In a box of markers and pens, 4/5 of the stationery are markers, and 5/8 of the markers are red markers. Okay, so we can either, there are many methods to do this. I'm going to draw a model to help us understand. So with this model over here, we see that 4/5 of the stationery. So if this refers to the whole stationery, then we have 4/5 that are markers. That means the 1/5 over here, pens. Now, and then we understand that 5/8 of the markers are red markers. So right now, the markers is 1, 2, 3, 4. But we know that 5/8 of this must be red markers, which means that I need to split this up such that it becomes 8. And if I split this up, I need to split the pens up as well. So from here, I know that 5 out of the 8 are red markers. And they ask what fraction of the stationery are red markers. So by observation, we can see that the stationery has now been split into 10 parts, 10 units. And out of 10 units, 5 are red. So the answer is half. Now, another way we can think about this is a multiplication of fractions. So if I have the total, I start from the total and I branch it out. 4/5 are markers, which means that 1/5 is stationery. No, sorry, 1/5 will be pens. 1/5 of the stationery will be pens. And out of the 4/5, 5/8 of the markers will be red. And the rest, 3/8, we have no idea what color they are. It's not stated in the question. So what fraction of the stationery are red markers? That means 5/8 of the 4/5 are red. So I need to take 5/8 of 4/5 is the same as multiplication. 5/8 of 4/5. How do we multiply fractions? So we can either do this, or we can simplify, and we see that 5 out of 5 can be simplified to 1 out of 1. And 4 and 8 can be simplified to 1 over 2. So we get 1 times 1, 1 multiplied by 1 over 2 multiplied by 1 to get 1 over 2 as my final. Moving on, question number 23. The table shows the number of apples sold by Mr. Gunn from January to May, and the bar for May is not wrong. Mr. Gan sold 80% of his apples from January to April. How many apples did he sell in May? So if we look at this question, and first figure out what all the data is here. So over here we have 1, 2, 3, 4, 5 gaps, isn't it? You count, there are 5 gaps. So every time you see a good habit will be just to find out what is the value of one gap, which is 20. So the value of one gap is 20. Here we have 8 gaps, 80, 120. So use your ruler because sometimes it might be in the middle. Okay, so this is 80. No, this is 6 because there are 3 gaps, 1, 2, 3. Okay, and then here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 180. Or we can see that is 1 less than 200. That's how we get it. So if he sold 80% of his apples from January to April, so we need to figure out January to April, what is it? So we take 80 plus 120, that's 200, plus 60 plus 180. So mentally, we can do that. This is 200 plus 60, this is 260. Then we plus 180. Let's do it side 260. Add 180. That will give me 440. 80% of his apples. 440 items. How many apples did he sell in May? So in May, this is 20%. All right, so in May, 20%, we can get 20% directly rather than finding out 1%. So remember, it's not always a must to find out 1%, especially if we do not have the calculator. We can divide by 4, and we will get 110 as our answer. Question number 24. The figure shows a right angle triangle ABC. So this is a big clue for us, right angle triangle. And it is folded along BD to form another triangle. So for folding questions, you need to know that this angle and this angle is going to be the same. So let's label that here first. This is 120 degrees. Find angle DBE. So angle DBE. Trace it out, DBE. That's the angle. It is part of a triangle DBE. So if I can find this angle over here, knowing that the sum of angles is 180, I can then find angle DB. All right, so angle DBE, I can find out angle DEB first, or BED, which is the same as angle B. So angle BED, which is the same as angle BAD, will be, so how do I find BAD? BAD is part of a larger triangle, right angle triangle. Can we see that? So we take 180, subtract 68, subtract 90. It will give me the angle over here. So I take 180, subtract 90, subtract 68. We'll get 22 degrees. So let's label on the diagram. In labeling, please use a pencil in school, just in case there's any mistake. It's easier to erase without ruining the diagram. So 22 degrees, and then we'll want to find angle angle DBE. Angle DBE, part of a triangle, 180, subtract 120, subtract 22 degrees. That will give me my answer of, I believe it is 60, subtract 22. Let's do it side. $38. And that's the final answer for question number 24. Let's move on to question number 25. So in question number 25, it's very important to see this word 12 unit cubes. Because if you were to count, right, what you need to assume is that there are no such thing as floating cubes, and the cubes are not glued together. Okay, so these are some assumptions that are usually not present inside the question. So they are not floating, they are not glued together. That means there must be something underneath it. So if we were to count, right? We may miss out that there is one more cube. So if I counted 1, 2, 3, 4, 5, 6, okay, 1, 2, right? Just by looking at this view, 5, 6, 7, 8, 9, 10, 11, 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then we will see that actually there is nothing at the back. Okay, let me count again. Right? So we might think that there's nothing at the back, but actually when we count 1, 2, so there are 4 over here. Okay, so let me count. Sometimes we can count systematically from left to right. So there are 4 here. The middle row I ignore first, the middle portion. Because there are definitely 2 here. We're not sure if there's 1 at the back. Then we count here, 1, 2, 3, 4, 5. There are 5 over here. Which tells me I have 3 more. So if there's 1, 2, there's 1 more actually that's hidden from view. So how does this look like? Okay, let's just look at the diagram here. So notice, this is how it looks. All right, at the back. Okay, there is 1 more cube that's at the bottom over there. Okay, so if you were to draw the top view must be drawn. Imagine that you are looking at it from the front, and then you draw the top view. All right, so what we would get to be, you can look at the 3D video again. What we would get be something like this. For the top view. Okay, so there will actually be 1 here. All right, and then for the side view should not be an issue. So the 12 unit cubes, we can just see it actually now from the side that it is 2 at the top, 2 on the second row, and 3 at the bottom. All right, so this is the answer, top view and side view. Okay, and the count of 12 is very important so that we understand and we can see that in this middle part, there are 3 cubes instead of 3. Okay, moving on to question number 26. 2/5 of the cost of a bag is equal to 3/4 of the cost of a shirt. Given that the difference in price between the 2 items is $56, what is the cost of the shirt? All right, so if these are equal, it means that my bag, which is going to be 2/5, this is 2 out of 5 of my bag, is equivalent to 3/4. That means 3 out of 4 for my shirt. So these two are equivalent. All right. So I'm just going to label this 2/5 bag equals to 3/4 of the shirt. So 2/5, if these 2 blocks is the same size as these 3 blocks, we need to equalize them, right? So this is the same size as this. So the lowest common multiple of 2 and 3, so if I were to list 2, 4, 6, then multiples of 3 and then 6 would be 6 units. So what I'll do is I'll change this into 6 units. So previously you might learn that you will, you split it up this way. You could do that because it's small enough. But what I like to do is to label inside. Okay, if 2 blocks is 6 units, it means that each block must be 3 units. If 3 blocks is 6 units, that means each block must be 2 units. All right. So if I built on the model and I wanted to find 5/5 of the bag. So right now it's 2/5 of the bag, right? So 5/5 of the bag means that this is 2/5. I need to become 5. And each of this will be 3 This is 3/4. I need to turn it into 4. So this will be 2 units. So what you will notice now is that I have all of the bag and all of the shirt. Okay, so the bag itself will be 15 units. The shirt is 8 units. The difference between the cost is 7 units, which is 56, and 1 unit will be 8. What is the cost of the shirt? 8 units, which is 64. Now, we can also use equating numerators to solve this. We can also use ratio. Okay, I'm going to use ratio because equating numerators and model is the answer key. So if I say that 2/5 of the bag, so every time you see a fraction, you can actually form a ratio. So 2/5 of the bag means I have 2 is to 5. This is referring to the bag, is equal to 3/4. That means I have 3/4. So this is the bag, and this is 2/5 of the bag. This is 3/4 of the shirt, and this is the shirt itself. So we are saying that these two numbers are equal. That means it's like a repeated identity. We need to make these two numbers the same. So we're going to change them to 6. So this will be 6, 15. And to change the 6, we must multiply the ratio by 2. So 6 to 8. Then, when we make it equal, now we can compare the 15 and 8 units. So we are actually using the same working. 7 units is 56. 1 unit is 8. The cost of the shirt, which is 8 units, will be 64. That is the answer for question number 26. Let's take a look at question number 27. Twice as many boys as girls attended the carnival. So we would have 2 boys and 1 girl per set, right? And we don't know how many sets there are of 2 boys and 1 girl. So this is 1 set. Okay, each boy received 3 coupons. 3, 3, and each girl received 2 coupons. And the children received 112 coupons in total. So let's figure out in 1 set how many coupons there are. There will be 8 coupons in each set. But we're looking at 112 in total. So we can figure out the number of groups or the number of sets. If we know that we're looking at all the way 112, so we are going to take 112 divided by 8. How do we do 112 divided by 8? So divide by single digit. 8, subtract 8, 11 minus 8 is 30. Bring down 4. So we get 14. How many boys were there? There are 14 sets. Each set has 2 boys. So the answer is 18 boys. Let's move on to question number 28. Okay, in question number 28, we have Mrs. Lee who made apple pies and chocolate pies. 85% of the pies were chocolate. So when we see 85%, we can form a ratio. So apple to chocolate to total. If 85% were chocolate, this would be 85 is 200, which means that apples must be 100 subtract 85, which is 15. We can reduce this by dividing by 5, and then we get 3 is to 17 is to 100, is to 20. So this is a ratio we can form, and this means that there are at least 3 apple pies for every 17 chocolate pies, and at least 20 chocolate pies. Okay, so we're told 3/20 of the pies that Mrs. Lee made were apple pies. This is true, because we have 3/20. Mrs. Lee made 51 chocolate pies. So let's check. It could be 17, it could be 34, it could be 51, as long as this is a multiple of 17. Next statement, Mrs. Lee made 21 more chocolate pies than apple pies. Sorry, this is not possible to tell. Huh? Okay, so it means that she could have made 51, it could be true. But at the same time, she could have only made 17, so that false. So if a statement is both true and false, then we will choose not possible to tell. Last statement, Mrs. Lee made 21 more chocolate pies than apple pies. So let's observe. The difference between chocolate and apples will be at least 14. And 14 is not a factor of 21. So 21 is not a multiple of 14. This is 14, if not 28, if not 42, so a multiple. So this is false. So a lot of students will put here not possible to tell. But you must know, you must assume for such questions it's not given to you, but you cannot have half of apple pie or half of chocolate pie, even though we know in real life there is. Okay, so if you see such a question, we will, because she will make pie, so we will assume that. Okay? And then we move on to question number 9. 14 books on each shelf, except for 2 shelves which were empty. So I don't know how many shelves there are, but I do know that there were a certain number of shelves. And then Melanie rearranged. But I do know that there were 14. So I'm just going to label this as 14. And I don't know how many there are. So this is a question mark. And there are 2 shelves that are empty. Right here, I should have 2 empty shelves. Melanie rearranged all the books so that all the shelves had 10 books each, meaning I'm going to have 10 books over here and another 10 over here. 10 books each. So this will be up to 10. Where did the 10 books come from? There were 2 empty shelves, right? It didn't just magically appear from somewhere else. So they needed to have come from the 14 books on each shelf that have now been reduced to 10. So you're removing 4 from each shelf, and each of this is actually being rearranged here. Okay? So if there are 10 here, we take 2 shelves of 10, the 20 books. Where did the 20 books come from? They came from the 14 books becoming 10 books. That means 4 books were removed from the other shelves in order to make up these 20 books in 2 shelves. So when you take 20 divided by 4, you are going to get 5. There were 5 shelves at first. Okay, so there were 5 shelves that had books, but had books at first. Okay, so number 13, last question. Table below shows the parking charges at a car park. The first hour is $2.40 from Monday to Thursday, and every additional 30 minutes will cut there. So cut there means that even if you cut for 1 minute after 1 hour, you still have to pay $1.80. All right. So Jane paid a total of $15 when she parked in the car park on a Thursday. All right, so this is a third. So we're looking at this. What is the longest possible length of time that she parked her car at the car park? Now, the answer is in minutes. So let's take a look at $15. So from the $15, we can split into $2.40 and this amount of money, which is 15 subtract 240. This gives me $12.60. So we need to figure out how many 180s there are in 1260. So again, paper 1, how do we divide? 1260 divided by 180. We can get rid of the zeros. So we get 126 over 18. So again, we're not very sure. Don't divide by 2 digits first. Divide by 1 is easier for you. So dividing by 2 is easier to get 63 over 9. And finally, 63 divided by 9 is 7. So there are 7 sets of $1.80, which means that there are 7 sets of 30 minutes. Including the first hour, we're taking 210 plus the 60 minutes in the first hour. Our answer will be 270 minutes. So this is what paper 1 is about, and we can move on to paper 2. All right, let's get started on paper 2. So paper 2 is 1 hour and 30 minutes long. It usually has 17 questions and is worth 55 marks. All right. You can use a calculator for paper 2. So let's take a look at question number 1 to 5 first, and they are worth 2 marks each. Okay, so first question, Jeremy had twice as many marbles as Kelly. So I can draw a model over here. He gave 70, so we can get rid of 70 here, and he gave this to Kelly. I will represent this with a dotted line for Kelly because it was added on. And then Jeremy had 42 more marbles than Kelly. So this is 42 and this will be 70. Looking at this, and we know that this is 1 unit. This is another unit because Jeremy had twice. We can take 1 unit to be 70 multiplied by 2 plus 42. And that will give me 182. So this is actually 182. How many marbles did Jeremy have at first? So if you look at the number of marbles that Jeremy had, he had 2 units of marbles, which is 364 marbles. And that's the answer for question number 1. Let's move on to question number 2. The table shows the length of 4 planks of wood, and we are told that the average length is 8.2 meters. Therefore, we can find that the total length is 4 times of 8.2, which will give me 32.8 meters. Write down one possible set of lengths for plank C and plank T. So we can subtract off the existing length of 10.7 and 8.5, and we will get 13.6 meters. So this means that these two lengths added together will be 13.6 meters. And any combination of this, as long as they add up to a 13.6 meters, you'll be fine. Okay, so an example of an correct answer would be 6.8 meters and 6.8 meters. Unless the question says they are 4 different planks of wood. So if they say different, then this answer is not acceptable. All right, so we need to look at the constraints. So there's no other constraints about different length, about it being a whole number, about one being longer than the other. So there are a lot of answers that are acceptable as long as they add up to 13.6. Moving on to question number 3. There were some oranges and pears in a box. The ratio of the number of oranges to the number of pears in the box was 3:8. So this was the ratio 4. And after 36 pears were sold, the ratio of the oranges to pears became 2:5. We have orange to pear, 3:8, and 2:5. 36 pairs were sold. So what did not change in the question? You will realize that the number of oranges remains unchanged. So we are going to make the oranges the same because it remained unchanged. So what's the lowest common multiple of 3 and 2? It is actually 6. To turn oranges into 6 units, I must multiply by 2 here, and I must multiply by 3 over here. So now we can see that for pears, the pears at first was 16 units, and the pears in the end was 15 units. So there is 1 unit difference. So 1 unit is 36. How many oranges were there in the box? We are trying to find 6 units of oranges. So we take 6 multiplied by 36 to give me 216. So there were 216 oranges in the box at first. Let's move on to question 4. So in question number 4, the figure shows a rectangular tank with a height of 12 centimeters. So this is unto 12 centimeters. How much more water is needed to fill the tank to the brim? So in order to fill it to the brim, we need to figure out how much space is. And the empty space has actually a height of 13 minus 12, which is 18. So you can find the answer by taking length times breadth times the height of the empty space. And when we calculate that, we get 16200 cubic centimeters. Question number 5, the last question of paper 2. So James bought a bicycle which included a GST of 9%, and before GST it was $180. So we need to figure out what is the 100%. So we find out that 100% is actually $180. I'll calculate this. It doesn't matter whether we find 1% or not, but I'm going to write it in this manner. So 1% is 180 divided by 100. You don't need to calculate this out. It's actually $1.80. So 109% is what he paid. So on my calculator, I will take 180 divide by 100 and multiply it by 109. So that will give me 109%, and that is $196.20. Let's move on to question number 6. And 6 is worth 3 marks. Okay, we have a container that weighed 7.4 kilograms when it was 5/6 filled with water, and the same container weighed 3 kg when it was 3/8 filled with water. So since it's the same container, we're going to make the denominator the same because the denominator refers to the capacity of the container. So 5/6 can be converted to 20/24, and 3/8 can be converted to 9/24. So let's draw a model to represent what this means. It means that the capacity of the container is actually 24 units. All right, whereas right now it's not being filled to its brim. Okay, so we have 20 units versus 9 units. Let me just write that down, what it means. All right, so this is 20 units, and this is 9 units, and this is the mass of the empty container. With the 20 units, it's going to be 7.4 kilograms. With the 9 units, it's going to be 3 kilograms. So we see that there's a difference over here of 4.4 kilograms, and that is 11 units. So I take 20 minus 9, get 11 units to be 4.4 kilograms. How much did the container weigh when it was completely filled with water? So to be completely filled with water means that it will be 24 units filled. So I could use the first number of 20 units and I add 4 units to it. So 1 unit will be 0.4 kilograms when I divide this by 11 on my calculator. And I'll find either 20, it's easier to find 4 units to add to the 20 units, which is 1.6 kilograms. So we add 7.4 kg to 1.6, and we will get 9 kilograms, which is the mass of the container when it's completely filled with water. Now, you can actually check. How do you check? You know that right now the container, if it's, let's use the second scenario, right? When it is 9 units full, it needs another 15 units to be filled to the brim. So let's find out what 15 units is. And this will be 6 kilograms. So we add 6 to 3 kilograms and we will also get 9 kg. So our check is correct. Our answer is indeed 9 kilograms. Moving on to question number 7. In the figure, the area of PQRST is 90 square centimeters. That means the whole area over here, this 5-sided figure, is going to be 90 square centimeters. Okay, and we are told that PT is perpendicular to TS. So this means that I have a right angle triangle and I can find the area of this right angle triangle. So triangle PTS area is going to be half times base of 12 multiplied by the height of 11. This will give me 66. So if I were to take 90 and I subtracted the 66, I will get 24. And that's the area of this unshaded area here. Okay, because I'm taking 90 and I'm subtracting this area over here. So I get 24. All right. So what do I do with this? I have to find the triangle RST. And triangle RST will be half multiplied by the base and then the height. So this will give me 84. So in order to find the shaded triangle QST, I can take 84, which is this triangle, and I subtract 24 and I'll get the shaded area. So my shaded area, shaded triangle will be 84 minus 24 to give me 60. Okay, then that's the answer. Question number 8. Jane had $124 more than Cheryl at first. So we could draw a model here where Jane has $124 more than Cheryl. Okay, so I'm going to draw a longer bar for Jane and a shorter bar for Cheryl, and then for Cheryl, and then this will be 124. So Cheryl then gave Jane 28. So this is Cheryl and Jane. So when Cheryl gives Jane 28, Jane increases by 28. So remember that there's going to be a hidden 28 over here. And then what do we have? We have Jane being 4 times as much as Cheryl. So the difference over here must mean that this difference, because it's 4 times as much, right? Okay, it's going to be 3 units. Okay, so my 3 units, the difference of 3 units, 4 units, 1 unit is 3 units. 3 units will be 124. You add twice of 28. That will give you 180. So that is 3 units. We can then find out what is 1 unit. And how much money did Cheryl have at first? So Cheryl didn't have 60 because this is after she gave 20. Add that back and that's your answer, $88. All right. Moving on, question number 9 and 10. So in question number 9, we are given that there are 130 red, green, and blue pens. So when we have 130, then there are 3 of them. So let's just observe there are 3 items, types of items. Red to green is 2:3. Blue to red and green is 3:10. So notice how there is a repeated identity of red and green, right? We can also work with the 130 and divide it by 13 units first because the total is 13. Okay, I'll just do one more step of changing this because 8 red and green together is 5. And since it's repeated, red and green, I will turn it into 10. So 13 units is 130. 1 unit will be 10. How many red pens are there? So the red pens is 4 units. So 4 units will be 4 times of 10, which is 40. And the answer is there are 40 red pens. Let's move on. In the square grid below, 2 sides of a parallelogram ABCD has been drawn. So since ABCD has been drawn and it's a parallelogram, now we need to think of these lines as they are diagonals of a rectangle. So this diagonal is of a square and BC is a diagonal of a 4:2 rectangle. Can we see that? So it is a diagonal of a 4:2 rectangle. Okay. So once I determine where D is, which is this corner, I can complete my parallelogram. All right, I will just do some quick labeling of the parallel sides and the sides that are equal. Part B, BC also forms one side of a right-angled triangle BCE. such that BC is equals to C. So if BC is equals to C and we're looking at a right angle, remember, we're looking at a diagonal of a 4 by 2. So this is a trick. So if you are looking at a right angle, either you can use your protractor, or since this is a diagonal of a 4 by 2, you will draw another diagonal of a 2 by 4. What do I mean? So let's take a look at this. So from C to E, right? This will be the same length and it will also be 90 degrees. Okay, so let me work it out, show you. Because I know it's going to be the same length, okay? So this is a diagonal of a 4 by 2. So if I put this over here, this will be a diagonal, a 2 by 4 rectangle. And this will be 90 degrees to this. So it's not just 90, it's also the same length as BC. And I will label this as BCE. Okay. Could there be other answers? They let me know. So the reason why it says within the square grid. So you could maybe have drawn like another, triangle like that, but it's not going to be 90 degrees. So, okay, and we want BC to be CE. That's why this would be the best answer. So you could have also done this where BC is equals to CE, but that's not going to give you a right angle triangle. Okay, moving on. Question number 11. A bakery had some cupcakes. 2/3 of them were bananas and the rest were walnut cupcakes. So I can form some ratios here. I'm going to use ratio to show you how we can organize the information, all right? So 2, 3, 2 and 3 over here, 2/3 of them were banana. We can form a ratio now, right? And then after selling 198 walnut cupcakes and 4/5 of the banana cupcakes, she had 1/6 of the cupcakes left. So we have of them. So by observing all these fractions, we realize that this is referring to the total. So this 6 over here of the cupcakes. This 3 is also referring to the total of them. Okay, so let's just form some ratios. All right, so banana to walnut to total is going to be 2:1:3. Okay, what else can I form? I know there is another fraction given to me, which is 4/5. So I will be able to form 4. 4 is not banana. 4 is what is sold. Whereas 5 is referring to the banana. That means there will be something that's left. So it will be 4:1:5. And she had 1/6 of the cupcakes left. So 1/6 means that I can form a ratio of 1:5:6. Or 5:1 because 1 is left. And that is 1 out of 6 was left. So there's a hidden number 5. Okay, so it helps to organize in this manner so we can see what all the numbers mean. And then we start to see what refers to the same thing. What is the repeated identity? So we know that the number of bananas here, this is one repeated identity. So I will make banana the same. 2 and 5 can turn into 10. So this will be 8:2:10. And this will be 10:5:15. All right, and she had 1/6 of the cupcakes left. So there's one more thing we need to make the same, which is the total. So the total here and the total here are referring to the same thing. So I need to make 6 and 15 the repeated identity. So let's turn that into 30. So let's multiply by 4 first, yeah? Okay, so to turn it to 30, I must multiply by 2 again. So I get 20:10:30. And we still need to change the one for the banana because now the banana needs to be the same. Let me use another highlighter to show you. So this is banana. This is the new banana, which is 20. So let's change it to 20. 16 is to 4 is to 20. Oops, I needed to change this as well. So now I have my new ratios that I can work with. Okay, and I'm going to box them up so that it's clearer that these are comparable ratios. So after now, how can we form a relationship with the number 198 walnut cakes? This was sold. So let's look at what's sold. Out of the 25 units, we know that 16 units were banana that were sold. So what does this mean? It means that out of the 25 units, if 16 were banana cupcakes that were sold, it means that the remaining 9 units must be walnut cupcakes sold. So 9 units is 198, and 1 unit will be 22. How many cupcakes did the bakery sell? So we're looking at sell. So we're looking at 25 units. Not in total, we just want how much is sold in total, not the total stuff. And the answer is 550. The bakery sold 550 cupcakes. All right, question number 12. Mrs. Roberts had a square piece of paper and she cut it along the dotted lines as shown in figure 1 to obtain one small square of size 7 cm. So it's over here, it's labeled. And 4 identical, so this is important, it is identical right-angled triangles, and one such triangle is shown over here. So we can observe that this is the 90 degrees, and 8 centimeters would be referring to these. This will also be 7 centimeters. So then we can see that 8 centimeters plus 7 centimeters will give me the longer line that is perpendicular to the 8 centimeters. Okay, so this is 15 centimeters. How do I know? So I add them together. 8 and 7 gives me 15. So this line highlighted over here is 15 centimeters. So what is the area of the square piece of paper before it was cut? We can add up these 4 triangles and the square to find the area. So I'll take 7, multiply by 7 to get the square. And to find each of the triangles is half times base times height. So as long as you identify the correct base and corresponding height, you'll be fine. So you get 60. So we have 4 of these triangles and the square that will give me 289. Don't forget your units of square centimeters. Part B wants the perimeter of the square piece of paper. So I'm going to do it at the top, okay, so that we can see the diagram. So the perimeter is actually these 4 lines. How do we find the perimeter? Now that we know the area, we can find the perimeter. Of course, we can do 289, we square root it, we realize it's actually 17 multiplied by 17. So the perimeter will be 4 times of 17, which gives me 68. Don't forget our units of 68 centimeters. The question is in centimeters, not meters. Let's move on to question number 13. So question 13 shows a figure, a square. So the word square is very important, being divided into 2 smaller squares, A and B, and 2 rectangles, C and D. This is a very important clue that the area of B is 4 times the area of A. So if the area of B is 4 times that of A, this is what's going to happen. Okay, I can split B into 4 equal parts, which is 4 of A. All right, so if we do this, okay, why was I so confident just now? Let me show you. So I'm going to call this 1 unit. So if one side of this is 1 unit, it means that one side of B is going to be 2 units. Isn't it? And these are equal lengths. So the one side of D will be 1 unit. And since the length over here is the same as the length of D, one side of D will also be 2 units. So the perimeter of D is 38 centimeters longer. So let's count. The perimeter of D is going to be 2 plus 1 plus 2 plus 1. Perimeter is 6 units. The perimeter of A is 4 units. Perimeter. So the difference between the perimeters are actually going to be 2 units, which is 38. So 1 unit will be 19. Find the perimeter of square A. Perimeter of square A is 4 units. And that will give me 76 centimeters. Now we have to find the total area of the figure. So there are many ways to do this. You can find them individually, or you can see that the whole figure is actually a square, and each side of the square is 3 units, which is 57 centimeters, right? So each side of the square is 57. So to find area, take 57 multiplied by 57, and we have our calculators. So with our calculator, we can easily calculate this out to be 3,249 square centimeters. And that's total area of the figure, question number 13. Okay, let's go to question number 14. So question number 14, we have a box containing some cards, and Elena took 1/4 of them and another 24 cards to her neighbor. So the 24 is not part of the 1. So if I were to work this out, this is what she took, 1/4, and another 24 cards. So these are gone, and I will drop down the model. So I call this a drop-down model. So it's easier to visualize without it being too messy. All right, so we drop this down, and she took 3/7 of the remainder. So out of this remainder, she takes 3/7. So this one will be 3/7 and extra 20 for herself. So we have extra 20. And then she's left with 40 cards. So by looking at this, we can now work back. So she has 40 cards left in the box. We can figure out that this is 4/7 of the remainder. So 4/7 of the remainder is going to be 60. Then we can find out what the remainder is, because it's 60 divided by 4 multiplied by 7, right? Because this whole thing over here is 7 of the remainder. So when we calculate that out, we get 105. I'm going to input that over here. Okay, so this 105 is the same as this 105. Now what do I do next? I know then this will be 3/4 of the total. And how do I find 3/4 of the total? I know it's 105 plus 24, which is 129. So to find the total number of cards, I need to find 129. I divide by 3, multiply by 4. I can easily do this to get 172. And that is my answer. Okay. You could work forwards, plug in the number. So if we take 172, so we can check. Right? From 172, she gave 1/4 of it. So that's 43, and another 24 cards to her neighbor. So the remainder, we can calculate that out. So we take 172 minus 43 minus 24, get 105. So the remainder of 105, 3/7. So you can calculate that out. 3/7 of 105 is 45. And another extra for herself, which is 60. And then we check, is this 40? Yes. So we are correct. Let's move to question number 15, last 3 questions. The figure is made up of isosceles triangles ABC and ACD. AB equals to BC as indicated in the diagram, and AC is equal to CD. Find reflex ABC. So isosceles triangle means that the base angles are going to be the same. So when the base angles are the same, all right, we can then find out what is this reflex angle. Also, we know what this angle is. Okay, so let's find angle ABC first, which is the apex angle. So 180 minus the 2 base angles, we're going to get 120 degrees. So the reflex angle, because angles about a point is actually 360 degrees. So we're going to take 360 and subtract 120 to get 214 degrees. And that is our answer. So given that angle BCD is 28 degrees more. Okay, so I'm going to just put the question here so it's easier for us to work with it and look at the diagram at the same time, just for purpose of this. So given that angle BCD is 28 more than ACB, so ACB is 30 degrees because that's the base angle of the isosceles triangle. So angle BCD is going to be 28 more than 30 degrees. So 30 plus 28 will give me 15 degrees. So this will be 58 degrees. So we're trying to find out what is the angle BAD, isn't it? Yep. So BAD is actually part of the base angle of ACD. So look at the base angle here. Okay, what we can do is we can find angle ACD first, which is 58 plus 30, get 88 degrees. Then we take 180, subtract 88, oops, and then we divide it by 2. Okay, to find this angle. Or it's actually, we are also finding angle CAD. So angle CAD, we are 180, subtract 88. Going to take, separate the questions. Angle BAD is going to be 46 degrees, subtract 30 degrees to get 16 degrees. And that is my answer. So that's question 15. Okay, last 2 questions. Question number 16. We have a tank with a square base of sides 20 centimeters and a height of 40 centimeters filled with water to a certain height. So we do not know what this height is. And the tank had a crack which allowed water to leak out. After 12 minutes, 1/4 of the water was left. So take note, this is of the water. Okay, not the capacity of the tank. So there was so much water and then 1/4 of it was left. After 15 minutes, they gave you the volume it's given. So what fraction of the water leaked out in 12 minutes? So you need to think. In 12 minutes, at first, it was not full of water, but there was a certain amount of water. And after 12 minutes, 1/4 was left, which means that all you need to do is to subtract the 1/4. It means that 3/4 of the water leaked out in 12 minutes. This is supposed to help us in part B. So what was the height of the water in the tank first? So this is a little bit of a rates question. So if I know that 12 minutes, right, I have 3/4 of the water leaking out. That means in 1 minute, what fraction of the water leaked out? So I can multiply my fractions. 1/12 multiply by 3/4. And I will get, so let me show you. You can use your calculator. Just show you what we can do. This will be 1/16. Okay, so in 1 minute, 1 out of 16 of the water comes out. Why do I want to do this? Because I want to figure out in 15 minutes. Then I realized that, hey, in 15 minutes, actually, 15 out of 16 of the water leaked out. So what this tells me is that if 15 out of 16 of the water leaked out and 800 cubic centimeters was left, it means that 1 out of 16 of the water was left. This is of the water, yeah, not of the capacity of the tank. So 1 out of 16 of the water is going to 800 cubic centimeters. So all of the water is going to be 16 multiplied by 800. And that will give me 12800. Now, the question doesn't want the amount of water, but the question needs the height of the water. So to find height, we will take volume divided by the base area. So I'll take volume divide by the base area of 20 by 20. Okay, so divide by 400. And that will give me 32 centimeters. So it was actually filled to a height of 32 centimeters at first. Okay, this is combining rates with volume. Okay, moving down to the last question, number 17. So we see some triangles over here. They are white and gray identical triangles used to form figures that follow a pattern. So we are told about the figure number. We can see that the white is 1 at first. Then it becomes 1 plus 2, so that's 3. 1 plus 2 plus 3 gives me 6. 1 plus 2 plus 3 plus 4 gives me 10. Okay, so it means that this must be 1 plus 2 plus 3 plus 4 plus 5. Then 1 plus 2 plus 3 plus 4 plus 5 plus 6. So that's 21. Okay, so what is the total number? So it will help for us to have another column for total number. You will realize that total number is 1. Then 1 plus 3 gives me 4. Then 3 plus 6 is 9. 6 and 10 is 16. 10 and 15 is 25. So I'm going to write that down. And we realize that these are actually, what kind of numbers are these? Square numbers. And how are they related? Oops. There. They are related to the figure number in this manner. 4 square gives me 16. 5 square gives me 25. 6 square gives me 36. So the total number would be 30 multiplied by 30 to give me 900. See, a figure in a pattern has 50 more white than gray triangles. So we can find the difference and observe that there is 1 more white than gray here. There are 2 more white than gray. 3, 4, 5, 6. So the difference between white and gray is always there is the figure number, right? It's exactly the same as the figure number. I do not need to manipulate anything else. So what does this mean if there are 50 more white than gray triangles? It means that it is figure number 50. If it's figure 50, then I can find that the total is going to be 2,500 or 2,500. All right? And there are always more white than gray. So in this case, it will be figure number 50, where white is 50 more than gray. And in total, this is 2,500. So what fraction of the total are gray? We need to find out what gray is first. So we take 2,500, subtract 50, divide by 2 in order to help me find out this gray. Okay, so we get 1,225 gray. What fraction of the total? You will find that it is 49 out of 100. And that's the end of the entire paper.